In this video, I'm going to show you about the second part of Lab 3. The second part of Lab 3 is asking you to measure the free running frequency of 565. The free running frequency means the frequency at which the VCO part of 565 is oscillating when there is no input. So first, let's look at the diagram of 565. From the diagram, you can see there are three parts inside 565, that is phase detector, VCO, and amplifying part. For the second part of Lab 3, we are going to work on this VCO part. Let's first look at the connection for this VCO part. There's pin 4, that is the output of VCO. So if we want to measure the free running frequency, we are going to measure from pin 4. And also there's pin 8 and pin 9 connect with timing resistor and timing capacitor. This timing resistor and timing capacitor determine the free running frequency. If you choose different resistor and capacitor, you should get different result. So if you cannot get exactly the same value as in the menu, you can choose a close one. There's another connection with pin 7, that is a VCO control voltage. If you change this control voltage, the frequency will also change. VCO means voltage control oscillator. So if you change the voltage, the frequency should also be changed. So the circuit we are going to use is one similar to this one. Since we are going to measure the free running frequency, so there should be no input, we will connect pin 2 and pin 3 to ground. And also we will disconnect pin 4 and pin 5. For the other connection, like pin 7 connect with 1N to the positive power supply. Another connection is connect to 10N and 10K to positive power supply. It should be the same. So here for pin 8, we connect with the timing resistor, which is 3.9K, and pin 9 connect with the timing capacitor, which is 1N. Now let's look at the circuit. So from this circuit, you can see this is pin 1. Pin 1 connect with the negative power supply. This is pin 2 and this is pin 3. Pin 2 and pin 3 connect with ground. This is pin 4. Pin 4 is our output. And this is pin 7, connect with 1N to positive power supply. Another connection is connect a 10N capacitor to a 10K and then to positive power supply. For the connection at pin 8, we have a timing resistor, which is 3.9K. It connects with pin 10. Pin 10 is our positive power supply. And at pin 9, we connect a 1N capacitor to ground. So that is pretty much our circuit. So here's the waveform on the oscilloscope. You can see from the measurement, the frequency is about 70 kilohertz. So that is our free running frequency. That means if there's no input, what's the VCO will oscillating. But note that if I change the voltage at pin 7, the frequency will change also. So now I'm going to turn on the power supply and then connect it with 7. So I connect a power supply at pin 7. And also you can see if I change the voltage, the frequency will change. So here now the voltage is 3.4 volts and the frequency is 122 kilohertz. If I continue to increase the voltage, you can see in fact the frequency is decreasing. Now you can see the voltage is 5.7 volts and the frequency is about 24 kilohertz. However, if I decrease the voltage, the frequency will increase. Now you can see the voltage is 2.2 volts and the frequency is 155 kilohertz.